De Titanoboa so enormous? How did it hunt? And what caused the end of its reign in the Amazon rainforest? Welcome once again to 90s History. The discovery of Titanoboa was not sudden. It began in 1994 when a local geologist, Henry Garcia, noticed a strange object in the Sarajevo mine that looked like part of a tree branch. At the time, no one paid much attention to it, and it was stored in a special box. Nearly a decade later, in 2002, another geologist, Fabiani Herrera, found a similar fossil at the same site. These geologists were primarily researching Paleocene flora to understand what the world's first tropical rainforests looked like. The real turning point came in 2007 when these fossils were sent to the Florida Museum of Natural History. There, scientists confirmed that the object was neither a tree branch nor a crocodile bone. When they compared its structure with the vertebrae of modern anacondas and pythons, they were stunned. The bone was 3 times larger and thicker than that of an anaconda. Experts immediately identified it as a snake vertebra. On one side was the fossil from the coal mine, and on the other was a modern anaconda vertebra. In science, size matters, and Titanoboa shattered every known record. Using mathematical models, experts estimated the snake's total length based on the size of its vertebrae. These calculations revealed that Titanoboa measured between 42 and 50 feet long, nearly twice the length of today's largest anacondas. It wasn't just long. Its body was as thick as a grown man's waist, and its weight was comparable to a sedan car, around 1,200 kilograms, nearly 10 times heavier than a modern anaconda. This discovery shocked the world. Titanoboa truly was the king of snakes. But the real question wasn't how big it was why it was so big. The answer lies in climate. Snakes are ectothermic, or cold-blooded animals. Unlike humans, they cannot generate internal heat and depend entirely on environmental temperatures. A basic biological rule states that the warmer the environment, the faster a cold-blooded animal's metabolism. A faster metabolism allows for greater energy, faster growth, and the ability to sustain a massive body. Titanoboa became a living thermometer of Earth's ancient climate. Its enormous body proved that 60 million years ago, Colombia's environment was far hotter than it is today. Temperatures likely stayed above 32 degrees Celsius year-round, with extreme humidity. This constant heat allowed Titanoboa to grow to unimaginable sizes. Today's Amazon rainforest, which already feels hot and humid, would actually be too cold for Titanoboa. If it existed today, it likely wouldn't survive there. Such a massive body required massive amounts of food. But how did Titanoboa hunt? Unlike Hollywood monsters, it did not chase prey on land. Its enormous weight made land movement inefficient and exhausting. Gravity worked against it, and friction increased with body length. Research suggests Titanoboa was slow on land and primarily an aquatic hunter, much like modern crocodiles. It spent most of its life submerged in swampy waters where buoyancy supported its heavy body. It was an ambush predator, lying in wait with only its eyes and nostrils above water. It could remain motionless for hours or even days. When an animal approached the water to drink, Titanoboa struck with lightning speed. Biomechanical models estimate that Titanoboa could exert over 400 psi of pressure while constricting prey, enough to instantly stop blood circulation and crush bones. Its diet included massive turtles and prehistoric crocodiles. Some turtles were over 8 feet long, yet Titanoboa could crush their shells with ease. Its teeth were designed not for gripping fish, but for breaking thick bones. Its diet included massive turtles and prehistoric crocodiles. Some turtles were over 8 feet long, yet Titanoboa could crush their shells with ease. Its teeth were designed not for gripping fish, but for breaking thick bones. For years, scientists lacked a skull to fully understand its feeding behavior. Snake skulls are fragile and rarely fossilize. But in 2011, an intern named Jorge Moreno Bernal made a once-in-a-lifetime discovery: a Titanoboa skull. It confirmed that its jaw could dislocate like an anaconda's, allowing it to swallow prey 3 times larger than its head. Water was not just essential for hunting, it was necessary for survival. Without water support, Titanoboa's own weight could crush its internal organs. Heat gave it power, and water gave it balance. It was a perfect creation for its environment. So why did it disappear? The answer is simple but tragic. The world changed, and Titanoboa could not adapt. After the Paleocene era, Earth's climate gradually cooled. Even a few degrees of cooling was deadly for a cold-blooded giant. Its metabolism slowed, digestion weakened, and hunting became inefficient. At the same time, swamps dried up, ecosystems shifted, and mammals began to dominate. Prey became scarce. No heat, no water, no food. Just a few degrees of cooling turned the world's largest snake into a fossil and a legend. We hope you enjoyed this 90s history video. Thank you for your love and support. We'll meet again in the next amazing video.